Hello all, welcome to Xerxez Solution. In this particular video, that is session 6, we are going to discuss about the concept of rational as well as complex number. In the last session, we have discussed about the integer floating point concepts and continue with that in session 6, we are going to discuss about the complex numbers. Okay, first and foremost, it is very important to know what exactly the rational as well as complex numbers are. Any number which can be expressed as a quotient or fractions in the form of p divided by q is called rational numbers. The fractions modules of Python library provide functionalities for rational number arithmetics. When it comes to complex numbers, is an element of a number system that contains the real number and a specific element denoted I called the imaginary unit and satisfying the equation I square is equal to minus 1. Moreover, every complex number can be expressed in the form of a plus bi, where a and b are the real number. We'll try to explore both the type of number called rational numbers as well as the complex number in this particular session. Let's dive into hands-on sessions. So the Jupyter notebook is handy with me. So let's start with the rational numbers. As far as if you want to work with the rational numbers, you need to install the library called fractions. Okay, so you can directly import these fractions from the main class called fractions. Now how to call the fractions. There is a method called fractions which itself is a subclass within the fractions, and you try to give the numbers here. In my case I have given 2 comma a 5. Okay, if I run this, okay, so this is already I have stored in the object called the n1. Now let's try to run this one. So it will display. I'm not going to perform any kind of the manipulations here. I'm just trying to display my rational number, okay, in the which is in the format of 2 comma 5, and I have stored that one in the object called n1. In the same way, I have taken here two pair of value 2 comma 5. And it is also possible to assign the single integer also. Okay, so in this case I have taken object n2 and the fraction is a number is 5 here. Okay, shift and enter it. If you run this, and you can see the format, in the format by default it has taken 5 comma 1. Okay, so two pair of number. Okay, the fraction rational number is displayed. This is in the case of single integer, understood? So if you want to perform a division, it is also possible to division here. In my case, I have taken one object called n3 and I'm performing 4 divided by 7. So it will give you, it will separate and give me the fractional number 4 comma a 7 here. Okay, this happens, this whatever the practice we have done, this in every cases I have taken integer type. It is also possible to have rational number using the concept of the floating point. For that one we need to import one more package called decimal. Okay, which subclass, there is a subclass called decimal which is inside the main class called the decimal. Try to run this one. Okay, so again I'm going to create an object called n4 and I'm going to assign the value as a 2.1, which is the floating point value. Okay, run this one. If you run n4, so it is going to give me some random numbers here. Okay, so this is for the 2 and this is for the 1 as far as decimal numbers are concerned. Okay, next we will try to discuss about floating point. Floating point, already we have already discussed how to work with the floating point. Okay, next let's try to discuss about the complex number, how exactly we can work with a complex number. As far as Julia is concerned, we had certain the problem here. We was trying with the Julia programming language. Okay, so the format of Julia programming language to work with the complex number is totally different from the concept of working with a complex number with Python is different. Here in Julia, generally we use IM, okay, but in the case of Python, we generally use J. J stand for here imaginary part, okay, and we have 3 and 2, which is nothing but this is the real part, and 2J is a okay imaginary part. But 2 and 3 are nothing but the integer here, okay, and I'm going to save this in the object called Z, okay, and this is a format 3 plus 2J, okay, which represent my complex number. If you run this one, type Z, I'll use a method called type to check the data structure, which type of data structure it is. So in my case it is a Z, okay, is a complex number, you can see here. Similarly, we can have addition. In my case, I've taken 3 point, okay, the floating point number 3.14 and 2.771J. This is also complex number. If you run type Z, so it is indicating a complex number. Similarly, you can compare this. Here 3 I'm assigning first, here in the case 3 last. So I have shuffled the format here. I'm going to compare this one, and it should give me okay the value as true. That means both numbers are same, both complex numbers are same here. Even in subtraction, if you take the case of subtraction, here also I have changed the format, okay, it should give me the value as true. That means both the formats are say either you go with the normal format, you can go with you can change it to the different formats. Now regarding about the additions, okay, so we can perform all the operations like addition, subtractions, multiplication, division, so and so forth. So I have taken the values like 2, 4, which are nothing but my integer. 3 and 5J, okay, are nothing but the imaginary part. So I try to find out, okay, the imaginary part as well as the real part, and I try to take the sum of those things. In this case, it has taken 6 plus 8J. Okay, so Python is very smart enough. Okay, it try to segregate the complete data, and it give you the accurate results related to your uh, the format of the data what we have used. Addition is also, now let's talk about the additions, how to perform additions in Python programming language, especially of complex number. Okay, let's try to have addition. So as far as addition is concerned, I have taken two objects, a1 and a2. A1 is having 2 plus 3j, a2 is having 4 plus 5j. So I'm going to combine this a1 plus a2, okay, and it is going to combine and is going to give me 2 plus 4 is nothing but the 6, and 3 plus 5 is nothing but the 8. Similarly, it is also possible to perform uh, subtractions also. 2 2 minus, okay, have a look on this, z1 minus z2, 2 minus 4, which is nothing but minus 2, okay, 3 minus 5, which is nothing but minus 2j it has given. Multiplication is also it is possible. 2 into 4 is nothing but, okay, so it is going to change the format here. Okay, so have a look on this, how 2 into that cross multiplication will take place here. Understood? The multiplication format is bit different as far as complex numbers are concerned. Next is conjugate. It is also possible to have the conjugate of the numbers, okay, which is nothing but the opposite of the opposite of your negative of your number z. I've given 3 plus 2j. So if you want to conjugate, just give the minus sign, okay, it will give you the reverse order, that is minus 3 1.4. Let me try to run this. So now you can see minus 3 minus 2j it has given. Okay, now next is it is also possible to combine different operands as far as complex number is concerned. Okay, let's try to explore this. Okay, so in this case, if you take the object b, I have taken 2 into 2. Okay, so 2 into 2, which is going to multiply 2 2s are 4, I'm going to get, and 2 into 3, which is nothing but the 6. If you run this, okay, b value, so you can see 2 2s are 4 and 2 3s are 6. It's possible to perform multiplication with the different categories, different types of operands. Not only in the case of addition, you can do it for subtraction also. Here 2 minus 1 is nothing but 1, okay, and 3 minus 1 is, okay, so it is not going to touch, only the real part it is going to touch here. Understood? So in the same way, even zero point 0.7 is a real part, 2 is a real part, so it is going to add 2, 2 plus 0 0.7. Okay, and going to give me the result as a 2.7 plus 3j, which is again a complex number. Not only in the case of real part, we can do it even the imaginary part also. In this case, if you take e equal to 2 plus 3j minus 0.7j, okay, so it is going to subtract zero point 0.7 from 3, and it is going to give me the exact value like 2 plus 2.3 already, because zero point 0.7 is already subtracted from that particular the value. Next, multiplication also same, but in this case I have taken floating point value. Okay, it gives me more floating point value, also support for different operand to work with it. G is equal to, next we have division part, 2 plus 3j divided by 2. Okay, so if you run this, okay, again it is going, you can see 2 divided by 2 is nothing but 1, and 3 divided by 2 is 1.5. The exact result it has given. It's so easy to work with the Python programming language as far as complex numbers are concerned. Next, I'm going to divide complex number with the complex number. If you run this one, and you can see imaginary part as well as the real part of the numbers are concerned. Let's now, from this session onwards, let's try to have some practical use cases. Okay, how all this, whatever the concepts we have learned so far, so how we can use this one in a practical use cases, we'll try to see. Okay, complex number, let us imagine that I want to take the square root of the complex numbers. How we can I can take it? So square root can be taken. There is a method called, you need to import the square root, which is available in math. Understood? So there is a method called square root. Method square root are used, and you can take the square root of your real time as well as the imaginary part here. So z, okay, so I think the z is having some values. Let me check what z is having here. In my case, I think z is having some 3 plus 2j, I guess, or else, okay, 3 plus 2j. Let's try to explore this. Okay, z real part I'm going to take the square of this one, plus z plus imaginary part I'm going to take the square of this one. Okay, square root I can take, so I'm going to get 3.60, okay, of z value. I think the z is having the value of yes, 3 plus okay, 2j, 3 into 3, 2 into 2, 4. Okay, like that it will try to take the values here. Okay, now next is, let's try to find out the geometrical center, understood, of any values. Other practical example I have taken here. Let me try to have find the distance between, let's say, 2 points. Okay, I'm going to get this value, find the distance between the 2 points. The next example, similarly, you can take the perimeter, centroid, so on and so forth. So here I have taken complex numbers. Miami, Florida, complex number. This is the values for real time and the imaginary part. Complex number, okay, this is how I'm mentioning. So and randomly I've chosen the Hamilton also, I have chosen randomly. Now if I want to take, what I will do, I'll try to geometric center object I will take. I'm going to take the sum of all this two, and I'm going to divide this to take the average. Understood? Miami, Florida, San John's, and Hamilton. Understood? So run this. So now I have divided, I have taken the sum, and I'm dividing that one with the 2. Now next, whatever the value I'm getting, okay, so that is the average value. Geometric center, what I have, I'm going to subtract that value with the Miami, John, okay, San John and Hamilton. I'm going to store that one in V1, V2 as well as V3. So run this one, it got executed. Now if you want to check the absolute values of V1, so you can run, there is a method called absolute APS and V1, so it gives you the value. Similarly V2 as well as a V3 you can give those. So these are the centroid actually. So using this one again, you can go with you can convert this one into the graphical presentations, and again further you can explore this value. I hope you are clear with the concept of rational numbers and complex numbers, but there are still a lot of areas where you can explore this complex numbers as well as uh, rational numbers as well as complex numbers, especially if you are planning your career in quantum computing, where playing with the numbers will have one of the vital role. So it's very important, okay, if you want to be a data science in future. So it's very important to learn the clear concept of rational as well as the complex numbers using Python programming language is concerned. Okay, so I'm going to wind up this. Let's try to meet in our next video lecture. Okay, till then you try to explore this. Thank you very much.